This is the solution to quiz 11. Okay, so we want to find the zeros. Well, this is almost completely factored, so that's x to 5 multiplied by x minus 3 to 1. I'll write the implied 1. And then this factors, so two numbers whose product is positive 4 and whose sum is positive 4, well, that's 2 and 2, so x plus 2 squared. So these are the factors, x, x minus 3, and x plus 2, and therefore we have the following. 0 is a 0 with multiplicity 5. 3 is a 0 of multiplicity 1. And negative 2 is a 0 of multiplicity 2. So, to be clear, and then the multiplicities are obtained from the exponents. 5, 1, and 2. Okay, so suppose g is a polynomial function of degree 3 with a 0 of multiplicity 2 and another 0 of multiplicity 1. Okay, so from the fundamental theorem of algebra, the fact that g is a polynomial function of degree 3 means that g can be expressed as some leading coefficient a multiplied by x minus c1 multiplied by x minus c2 multiplied by x minus c3. Okay, so then a 0 with multiplicity 2 at negative 1, that means that negative 1 is counted twice. So this negative 1 here we can put into two slots. So I'll put it in that slot and that slot. And in addition to that, we have another 0 of multiplicity 1 at 3. That means that it takes up one slot. So we have all the slots figured out. So that'd be a multiplied by x minus negative 1, so that'd be plus 1, and then plus 1, and then x minus 3. Simplifying slightly, that would be a x plus 1 squared times x minus 3. Now, we don't know what a is, and we'll use the last piece of information that we have, is this. We'll use this to figure out a. So that's saying that when you plug in 0, you're supposed to get 6. So 6 is g of 0. But if we put 0 in here, that's saying that it's a multiplied by 1 squared multiplied by negative 3. So 6 is negative 3a, so negative 2 is a. And therefore, we have determined that g of x is negative 2 multiplied by x plus 1 squared multiplied by x minus Okay, so we're given this polynomial. Answer these questions and then sketch. Okay. So this has multiplicity 2 plus 2 plus 1. So the multiplicities are 2, 2, and 1, so that means that f is degree 5. So the fact that it's degree 5, its degree parity, is odd. The sign of the leading coefficient, if we were to multiply all those out, we would have an x to 5 with positive 1 is its leading coefficient. And that means that the shape, the global shape of this polynomial has to look like this. So up going to the left, down going to the right. Up going to the right, down to the left. And then it's got some kind of wiggle in here. So the zeros is what tells you about the green local part, and the degree and leading coefficient is what tells you about the red global part. So the number of zeros is 1, 2, 3 unique zeros. 3 unique zeros. That's to say, not counting multiplicities. We'll count the number of turning points after the sketch. So as x goes to the left, y goes down. As x goes to the right, y goes up. Okay, so we know that 0 is one of the points, negative 4, 2, 3, 4 is one of the points, and positive 6, 1, 2, 3, 4, 5, 6 is one of the 1, 2, 3, 4, 5, 6. Good. So we know that we need to start down here and end up here. And the question is we need to wiggle through this. So now, negative 4 has multiplicity 2, which means that we have to bounce off of that one. So we come from down here and we bounce off of this one because it has even multiplicity. So now we need to come back up to this 0. We need to come back up to this 0, and that's where x is 0, and that's a crossing because that is an odd 0. So now we're going to have to come back down to this one, and that's even multiplicity. So we come back down to this one, bounce. So that's the answer to question 2. Okay, divide polynomials. So 2 is guarding the door. The coefficients up here are 1, negative 4, 6, negative 5. So carry and then multiply, add, multiply, add, multiply, add. So the quotient is 1x cubed minus 2x squared plus 2x minus 1, and the remainder is negative 1. So the quotient comes from, oh, what happened here? Ah, okay. So I'm going to leave this on the camera because I was rushing too much. I'd like for you to observe what happened. So I made an error. So this is wrong. Okay, so this is wrong because I left off the 0 x cubed's term. So there needs to be a 0 right there. So that whole thing is off. So let's try that again. So 2 is guarding the door, and then now 1, x to 4, 0, x to 3, negative 4, x to 2, 6, x, negative 5. Okay, so let's try not to rush. 1, so carry down, and then multiply, add. Multiply, add. Multiply, add, multiply, add. So let's double check that now. So 1, 0, negative 4, 6, 5. Multiply, add, multiply, add, multiply, add. Okay, let's try this again now. So quotient is x cubed plus 2x squared plus 0x plus 6. So now this comes from this, and the remainder is 7, which comes from that. Okay, so now the area of a rectangle is that, and the length of the rectangle is that. So we have a rectangle whose length is 2x minus 1, the width is unknown, w, and the area, the product of those two, is 4x cubed plus 16x squared plus 5x minus 7. So we know the product of these, 2x minus 1 and w, is that cubic. So to solve for w, we need to divide the cubic by 2x minus 1. Okay. So 4x cubed plus 16x squared plus 5x minus 7 is to be divided by 2x minus 1. Okay. So this is the leading term inside the house and the leading term outside the house. So we take these two terms over here for some work. So 4x cubed over 2x, well, that is 2x squared. So 2x squared. Now that 2x squared is a partial quotient, and it gets put on the top of the house. So 2x squared. And then we take this partial quotient, 2x squared, and we multiply it by the divisor, 2x minus 1, and we write the result under the current dividend, 4x cubed minus 2x squared, and we're going to subtract that much from the dividend. Okay, so this, put right there. So I can tell I probably did this step correctly because there'll be no more cubes when we're done. And then 16x squared minus negative 2x squared will be 18x squared, and then carry down, plus 5x minus 7. So now this is the leading term inside, and that's the leading term outside. So again, we'll carry these over here for some work. So 18x squared divided by 2x, well, that's 9x. So that partial quotient also gets moved to the top. So 9x multiplied by 2x minus 1. We're going to write that over here, so 9x times 2x minus 1, that's 18x squared minus 9x. We're going to subtract that much. I can tell I probably did this step correctly because there will be no more x's when that's finished. So no more x squareds, and then minus negative 9x, so that's 14x minus 7. So now this is the leading term inside the house, and that's the leading term outside. So we're going to take those terms over there for some work. 14x over 2x, well, that's 7. So that partial quotient gets put on the top of the house. We're going to take that partial quotient, multiply by the divisor, write it under the current dividend, and subtract. I can tell that I probably did this step correctly because there'll be no more x's, and conveniently we get nothing at all. Of course, it's necessary that we would have had no remainder, because after all, the question was saying that the product of 2x minus 1 and w should be this. So there should be nothing remaining after this. So therefore we can conclude that the width is this quotient. 2x squared plus 9x plus 7.